Assalamu alaikum with another topic. Today we will discuss the solid state of matter. The state of matter in which the interparticle attractive force are so strong to keep the particle at its fixed position is said to be the solid state of matter. In solid state of matter, the particles are closely packed and fixed at its fixed position. In solid, there occurs a strong force of attraction between the solid particles, which hold them firmly together so that they cannot leave their fixed position. Such type of state of matter will have only one type of kinetic energy, which is said to be the vibratory motion. So the particles of the solid can have kinetic energy in terms of vibration. They have to and fro motion at its fixed position. There are some properties of solid which make it different from liquid and gas. The first is definite shape and volume. As there is strong interparticle attraction between the particles of a solid, that is why they have a definite a fixed shape and fixed volume. As we discussed earlier, that it's solid, the particle have only vibratory motion. The particles of the solid cannot move freely. It cannot leave its fixed position. It cannot move from one place to another place. Therefore, we say that in solid, the as the particle are at its fixed position, so they will have a fixed shape as well as a fixed volume. Melting point. The particle of a solid only vibrate at its fixed position. It has only to and fro motion. It doesn't move from one place to another place. When a solid is heated, then the vibratory movement of the particle increases. When the vibratory movement of the particle increases so much that it overcomes the interparticle attractive force, then the particle leave its fixed position, and at that time it move all around this all around the solid. So we say that the solid now start melting. So the temperature at which a solid start melting is said to be the melting point. And the reason of melting is when we know that the temperature is directly proportional to kinetic energy. This is a known property that temperature is directly proportional to kinetic energy. So when a solid is heated, its molecule having kinetic energy in term of vibration increases. The increased kinetic energy, the increased vibratory motion decrease the interparticle attractive force, and as the temperature increases, the kinetic energy further increase, and a time reach when the kinetic energy overcome the intermolecular forces. At that time, the particle of the solid leave its position, and we say that solid change into liquid. So the temperature at which a solid state of matter change into liquid is called melting point. So at melting point, the particle of solid leave its fixed position and hence melt into liquid. And as I mentioned earlier, that as the temperature increases, the vibratory motion of the solid particle increases, which reduce the interparticle attractive force, and at the end a solid change into liquid state. So melting point can also be defined as the temperature at which the solid state of matter start changing into liquid state is called the melting point. So solid change into liquid. When solid change into liquid, the process is called melting point, and when liquid change into solid, then it is said to be freezing point. Remember that at melting point, the temperature of the system remains unchanged until all the solid melts. It is somewhat similar to the boiling point, that at boiling point, the temperature of a liquid remains constant, no doubt how much heat is supplied, and we have explained it that extra heat is utilized to break the intermolecular forces. Here, when a solid starts melting, till it melts completely, the temperature will remain constant. So melting point is the characteristic of the crystalline solid. Remember that the melting point of a liquid tells us about the purity of the solid. If a solid is absolutely pure, then it will have a fixed melting point which has been given in the literature. Otherwise, if a solid is impure, its melting point will be lesser than that is given in the literature. So to check whether the given solid is pure or impure, we have to find out the melting point. If the melting point of the solid is that one which is given in the literature, will tell us that the solid is pure. Otherwise, if it containing impurities, then the melting point will be lesser than that, which is will be less than the melting point which is given in the literature. The third point is the rigidity. Particles in the solid are closely packed and cannot leave its fixed position. Rigidity is the resistance in the deforming of a solid. It means that the solid particles are so closely attract each other that it resists the deforming force. So particles in solid are closely packed and cannot leave its fixed mean position. Therefore, solids are rigid in their structure. Solid has greater density than liquid and gas. So the fourth property of the solid, that it has density which is greater than liquid and gas. The density of the solid is greater than that of gas and liquid. It is because strong interparticle attraction which bring the particle of solid closer to one another. As a result, the close packing results the decrease in volume. So as the volume decreases, the density will increases. That is why if we have a substance in two physical state, liquid and solid, then the substance which is in solid state will have lesser volume and it will have greater density by keeping mass of both state constant. There are so many types of solid. On the basis of the arrangement of particle, we have to classify solids into crystalline solid and amorphous solid. So what are crystalline solids? The solid in which the particles are arranged orderly in regular three-dimensional patterns forming a geometrical shape. It means that in crystalline solid, the particle will have orderly arrangement. The arrangement will be in three dimensions, along x-axis, along y-axis, along z-axis, and after the arrangement of the particles, the crystalline solid will have certain geometrical shape like cubic, trigonal, etc. Particle may be, as we have discussed earlier, that particles, when we say particle, then we mean that particle may be ions, atoms, or molecules. They have different, in crystalline solid, have definite faces. Each face have a definite angle with the other face. Look at the structure of a crystalline solid given, which represent sodium chloride, and we know that the structure of sodium chloride, the geometrical shape of the sodium chloride is cubic. Now how can we explain crystalline solid by taking this geometrical shape under consideration? As we mentioned earlier that a crystalline solid have definite faces and each face has definite angle. So look at this. These are the different uh, faces of crystalline solid. It is just like a cubic box. And these faces has certain angle with the next face. For example, let's say I select this point. So these are the particles. The dot in the cube represent the particles. These particles are arranged in three dimensions along x-axis, along y-axis, and along z-axis. So these faces are representing the length edge in a crystalline solid, and each edge has an angle with each other, which is represented by alpha, beta, and gamma. So in short, we'll have to discuss it in senior classes, but in short, that in crystalline solid have certain definite faces, and each face has definite angle with other face. And look at this, these angles and edge length is called unit cell dimension. So for every crystalline solid there should be a definite length between the two particles, and it will have certain angle with it. So the crystalline solid is known from the crystallographic elements, or it is represented by unit cell dimension. We will discuss it in the senior classes, inshallah. Crystalline solid has some properties which make it different from amorphous solid. Number one, they have sharp melting point. The sharp melting point means that all the solid melt at fixed melting point. So when a solid melts at fixed melting point, a temperature at which all the solid simultaneously melt is said to be sharp melting point. It doesn't mean that high melting point. The sharp melting point means that melting of a solid, all the solid at a particular temperature. So when a solid melts at a single temperature, all the solid melt at a single temperature, then the melting point is said to be sharp melting point. Crystalline solid has definite arrangement of particle. The particle arranged definitely orderly in three dimension, and when they arrange in three dimension they will have certain geometrical shape. Example of crystalline solid are sodium chloride, naphthalene, diamond, etc. The second solid is said to be the amorphous solid. So it is somewhat opposite to the crystalline solid. The solid in which the particles are not orderly arranged, forming no geometrical shape. In amorphous solid, there is a lack of orderly arrangement of particle. Means the particles do not arrange orderly. They are arranged irregularly, having no definite angle, having no definite length between the particle. Similarly, they do not have sharp melting point. If we differentiate between crystalline solid and amorphous solid, then crystalline solid has sharp melting point, while the amorphous solid do not have sharp melting point. Similarly, they do not have definite arrangement of particle, while the crystalline solid has definite arrangement of particles. Thirdly, they do not have definite geometry, as the particle do not arrange orderly, therefore they do not have definite geometrical shape. Examples of the amorphous solids are plastics, rubber, glasses, etc. So it is all about the properties of solid and the types of the solid, the crystalline and amorphous solid. So thank you and have a nice day.